Hello, and welcome to our showcase presentation. I'm Jared Sabota,
And I'm Brock Williams.
and our sponsor is the Munroe-Meyer Institute of UNMC, and our project is Habit VR. So a bit about Munroe-Meyer Institute, or MMI. MMI was founded in 1919. Their core mission is to transform the lives of individuals with intellectual and developmental disabilities through innovative research and extraordinary patient care. They serve more than 70,000 people each year, serving clients across the lifespan, and they have more than 50 types of services provided.
So a little background on our project. Cerebral palsy is the third most common pediatric neurological diagnosis in the United States. One successful therapy technique that's used to improve motor actions for children with cerebral palsy is hand-arm bimanual intensive therapy, or HABIT. The Munroe-Meyer Institute hosts a habit therapy camp for 60 hours across 2 weeks. And for our project's funding, it came from the Munroe-Meyer Guild. Their mission is to improve the quality of life for persons with disabilities through fundraising for the UNMC Munroe-Meyer Institute. We also wanted to thank our sponsor, James Geringer, as well as the other project stakeholders a part of our project.
So for a brief introduction for our teams, as a co-team model, we had two teams. So for the first team, 3 Mod 2, we had Ryan as our development manager, myself, Brock, Kyle, and Chase as developers. And then for our second team, signed Pi over 2, we had Ethan as our product manager, Demetrius, Grant, James, and Jaron as developers. And lastly, for our project faculty, we had Melanie Kugler-Wright as our project manager, Chris Bone and Jeff Falkenberg as our tribe leads, and Steve Colby as our coach.
So the problem our team solved was the occupational and physical therapy departments at the Munroe-Meyer Institute worked together to host habit therapy camps. During these camps, the therapists come up with various age-appropriate fine and gross motor bimanual activities that are delivered in a play context. However, these interventions are delivered for 60 hours across 2 weeks, and the patients often became disengaged with the activities. Our team helped create an immersive, narratively driven, escape room-like experience in a virtual reality video game to be used in physical therapy. We utilized advancing virtual reality technologies to encourage engagement in therapy and maximize therapy time, and provide a tailored and customizable experience through a therapist user interface.
So like Brock was saying, in the end what we were able to make is an escape room-like game that can be broken down into 3 main levels. The first one is the tutorial, otherwise known as the training center. This consists of 5 minigames to help the player get accustomed to VR and learn the fundamentals that they'll need later on. In addition, there's a narrative setup with 2 voice-acted characters that introduce them to the plot of the game.
Welcome to Habit Recruit. This is the Habit Training Center. Today, we will be training you on how to be a habit agent. As a habit agent, you will help hunt down and capture evil villains. We lock these villains up in the basements of this facility. You have probably heard of some of the notorious doings of the villains we have, like Dr. Sphinx, the puzzle mastermind. Our duty as habit agents is to keep the world safe. But first, you need to complete your training exercises. Use your habit controller devices to teleport to the door and press the button when you are ready to enter the next room. Your habit controllers come equipped with an anti-gravity device. This will let you pick up objects of any shape and size. Walk over to those boxes on the table and move them into the area on the other side of the room.
Finally free! No one can contain the diabolical Dr. Sphinx!
Oh no! Dr. Sphinx has escaped and put the facility on lockdown. We can't let him get away. Recruit, you will have to solve the puzzles Dr. Sphinx has made to catch up to him. Hurry!
Secondly is the random dungeon. This consists of 3 branching paths. Each path is randomized and can be customized. In this level there are over 10 minigames presented to the player in a random order. Lastly, there's the final level where you face off against the villain of the game, known as Dr. Sphinx. It's broken down into 2 sub-levels, and there's 3 mini-games and a final narrative cutscene to this.
Looks like Dr. Sphinx was expecting us. Watch out for those shield turrets. I'm enabling your shield gadgets now. Maybe if you deflect those turrets' projectiles, you can weaken the barrier.
Since these minigames were being made for the purpose of physical therapy, we identified aspects of design that each game must follow in order to be most beneficial to the patient. Firstly, each game must incorporate a range of physical movements that challenge the player in unique ways. These movements must be designed around the upper extremity classifications. These include manipulator, where the hand or arm is being used to produce a desired effect. This could be something as hitting a hammer with a nail. Assister, where the hand or arm is being used to help perform a task. This could be where two hands are being used to unscrew a jar. And lastly, a stabilizer, where a hand or arm is being used to maintain an object's position while another hand is doing the bulk of the task. This could be something like holding a cup while pouring something to drink. Lastly, each of these games must force usage of both hands simultaneously. One thing that's common with patients with cerebral palsy is one hand or arm is weaker than the other. Thus, forcing the patient to use both hands is pretty essential to the games. Another thing that was important for our project was accessibility and scaling options. One thing that was very important for providing these options is a therapist UI that allows the therapist to make runtime changes, such as adjusting the game's difficulty, adjusting the overall length of the game, changing the game's handedness or what hand is being forced to be used at a given moment, and changing the control scheme. Another thing that's important on this front is utilizing multiple modes of feedback, including visual, auditory, and haptic. Combining all these together provides the best experience for the players. And lastly, while working on our project, we learned that colorblindness is actually more prevalent in kids with cerebral palsy. Thus, designing around colorblindness was very important to our project. One takeaway we had in this area is that color can be important to the design in our games, but should never be essential. Additionally, when necessary, these color-based mechanics should be supported by visual indicators.
So in the end, we were able to produce a full VR therapy game with full replayable story mode, including a tutorial and final level. We have over 10 puzzles throughout the game with accessibility options and difficulty scaling in each of those puzzles. And we are providing a direct impact in helping improve bimanual coordination in children with cerebral palsy, and we hope that they will have fun while doing it. Some of the highlights throughout the project for our team was developing and creating a story and narrative process for our game, developing with accessibility in mind and learning about how to do that, as well as making the game modular and able to fit a replayable design. Lastly, we wanted to again thank James and MMI for sponsoring this project and helping us along the way. Our team was really motivated by this project and had a lot of fun working on it. And we're really proud of the result. So on behalf of all of our team, we just wanted to say thank you and